Hello, everyone. Welcome to the show. I'm Chris Fox, the low voltage systems lead engineer here at Munro. I've been with the company since September of 2010, so it's been a little while. And I'm here today with Mr. Colt Correa from Intrepid. So thank you for joining us today.
Thank you. Great to be here.
So you've got 26 years of experience with automotive Ethernet or Ethernet in general?
Ethernet in general, just automotive Ethernet is the only experience that I do have.
Okay.
And that started when automotive Ethernet started around 2008, basically.
Okay.
Between 8 was really the introduction with BMW, just with diagnostics only. But then it really started roaring heavy 2014 timeframe. That's when we decided to, get in the market as a company of network tools, and as well as to write the book Automotive Ethernet, the definitive guide at that time as well.
Okay. So what got you into that industry in the first place?
The automotive industry? I was born, my father was a tool and die maker. He was in the automotive industry. I always wanted to be in the automotive industry. It always fascinated me. Rebuilt cars as a kid with my dad. And but interestingly enough, everything in my world was mechanical, but I was always fascinated with circuits. Like even since I was in middle school, just opening up like a radio or, pulling out home electronics and looking at the schematics. I'm like, I want to learn how to do that one day. And it was never a choice. So I just went in electrical engineering, and it's been a great ride since then. And just combined electrical engineering with automotive engineering. It was a great time to enter the world as well, because that was back in the early 90s.
Yeah, that's true.
And electronics back then compared to now, it's just
night and day difference.
Yeah, just in its infancy. So I've ridden the wave for the past almost 30 years now, just in the growth of electronics and with the industry, and it's been fantastic.
So BMW aside, with them basically introducing Ethernet to the automotive world, or any other like major milestones that?
Yeah, the biggest milestone in automotive Ethernet was when it was BMW that first had the idea to adopt Ethernet for automotive applications. And in general, what you see, we have here an RJ45 with a standard Ethernet. We call this, the official name is 1000 base T. But Ethernet was already ubiquitous, of course.
Right.
Everyone knows this. It's by far the most widely used networking technology ever. And its dominant role outside of automotive. I also used to get the question even in the 90s, why doesn't the automotive industry use just Ethernet? And
Yep.
There's some good reasons for it. First, the standard Ethernet that we have, the 1000 base or gigabit Ethernet, it has 8 wires. And in the automotive, 8 wires is really bad. Almost all networking technology before Ethernet in the automotive was either 1 or 2 wires.
Correct.
So just the weight and the cost and the expense, especially when we consider all the connectors that have to be watertight, temperature, so forth, it was just too much. That was one thing. But in addition, the frequency, the main frequency baseband that this runs at, it has harmonics that overlap right on top of the radio band.
Ooh,
So without shielding and special consideration, standard Ethernet does not meet the EMC requirements. And in 2008, when BMW introduced 100 base TX, it's 4-wire Ethernet, but nonetheless, it's non-automotive Ethernet, a standard Ethernet. They introduced that into their vehicle. The key to that introduction was the fact that it was only going to be used for diagnostics. So the Ethernet network was only active when the car's in, like, for a shop and at the dealer or a service bay or something like that. Therefore, the EMC concerns that you have about the radio band sort of go away.
Yeah, I'm kind of struggling with that one. It's like only used for diagnostics. I mean, typically it's used for infotainment, ADAS, and now
that's where we're at today.
Now
right.
The move to like a zonal architecture.
Yeah.
Okay, now we see a lot more of it. And that makes more sense.
So the biggest really for automotive Ethernet, the biggest step was BMW got with Broadcom, California, or I guess I should say, I don't know if they're California, they're based in Jamaica, I think, or something like that. But anyways, most of the engineers are in California, and they got together, and Broadcom had already an existing technology called broad R-reach, and it was basically 2-wire Ethernet that they developed for the telecom industry.
Okay.
And so they agreed to adapt this broad R-reach, this 2-wire Ethernet for automotive use cases, and they were able to meet all the MC requirements, and then that introduced a 100 megabit Ethernet. And by comparison, the more standardized or what was the ubiquitous network that was in existence at the time for the last 30 years, it's been so dominant. It's called CAN, Controller Area Network. Yep. And then we have CAN FD, CAN Flexible Rate. There's a couple of variants, but that's still, you could argue that's still the dominant network.
It definitely is.
But so most of those networks are run at 500 kilobits per second when we look at practical application inside the vehicle. So we're going from 500 kilobits per second to the first version of Automotive Ethernet was 100 megabits, 100 megabits
orders of magnitude.
So it's like way orders of magnitude larger. So and in addition, the industry was so excited about it at the time just because there's so many technologies built on top of Ethernet. So anything in the internet is basically built off of any type of protocol or functionality, video, anything, transferring data is on top of Ethernet. So bringing in essentially an Ethernet that is only different at the physical layer. So the only difference is the wiring between Automotive Ethernet and what's ubiquitous everywhere else. So all the protocols that exist and have existed and have been well proven, cybersecurity methods and so forth over the internet can be brought right into the vehicle. So it was such a huge draw for the automotive industry that it became a standard, and now it was standardized through IEEE. Now its official name is 100 base T1. T1 indicates that there's two twisted pairs, and that was designed for the automotive industry. And since that time, we've seen pretty quick adoption of the 100 base T1 technology into applications like infotainment. That's where we first saw, because it's infotainment needs a higher bandwidth than what other networks can support, like controller area network, for example, and then it's not as dangerous as just going right into like an ADAS application with some new technology.
Yeah. So back to infotainment, where do you see the benefits between Ethernet versus A to B?
Well, it's a very good question.
A to B is audio to bus.
Yeah. A to B is another technology that's very popular for audio. It's literally named audio
to
bus.
Yeah.
Specifically for adapted by analog devices for a lot of automotive applications. So that's a very good question. I see that Ethernet is more of a generic technology. So if you build an infotainment network around Ethernet, there's all protocols available called audio video bridging that's used outside of, mainly in professional audio and video, like in stadiums and stuff. That's been brought into automotive use case for infotainment. So you can make an argument that an Ethernet network, one advantage that it has is that specifically over A2B is that the Ethernet is more generic and can be used for other things, not exclusively just infotainment. So you can have other types of data on that network, software downloads, streaming, that kind of thing. I would say though that to be honest, A2B, trying to be neutral here, is got a lot of advantages over Ethernet, and that is that it's specifically designed for audio data, which means it runs at a frequency that's good for audio at the 44 kilohertz. Or 48 kilohertz is more standardized. There's some applications of 44 kilohertz in Europe. So excuse me, most applications are at 48 kilohertz, which is the standard audio rate for like CDs and most audio, even professional audio applications. So that's that. And in addition, you put the chips down and you immediately can put into the ADI chips streamed right in, direct in or out audio data. So essentially, you're eliminating a lot of software. That by choosing A to B over Ethernet, you have to implement a lot of the streaming mechanisms, AVB, time synchronization. This all has to be implemented in some way, and for many ECUs, it's in software. So to avoid additional software effort, testing, and so forth, you can use ADI as a quicker means to get something to market that functions. And so I have actually seen a lot of adaptation of A2B around the world for that reason. It's simply quicker to market, less engineering resources to get it to function. But again, the advantage of Ethernet that I see, it's more generic, can be used for other things other than just Ethernet.
Now, do you see Ethernet?
Just audio data, I mean. Yeah,
do you see Ethernet sort of pushing other bus technologies out of the way in automotive? Because typically, like CAN's the go-to, Lint for some things.
Yes.
Like FlexRay seems to, and was a K-Link seem to be on their way out.
The exciting thing that happened at the time, and this is past history, before Ethernet, one of the dominant networks that was used specifically for infotainment, specifically designed for automotive infotainment, was MOST. media-oriented serial transport. And this was ubiquitous with European manufacturers. You name a European manufacturer, Daimler, BMW, Volvo, Renault, they all used most. Most is 100% at this point in time historically toast. And at that time, we used to say, most is toast at that time. And I was actually working with the people that made most, SMSE. It's a company, SMSE now, and since then, Microchip has bought them. So they got bought and into the company of Microchip. But they were fighting really hard. And you can see working with these engineers, they felt something really bad happened with their career. And all of those engineers now, the same people that I work with through IEEE and everything are all on different various forms of Ethernet now. So that's one for sure where Ethernet supplanted and just completely eliminated the most technology from the automotive landscape. And what we see now is a bigger push as well, especially with controller area network, as you mentioned, practically speaking. The fastest that you can go with that is 500 kilobits per second. So we're seeing control applications even now that require more bandwidth than that. And and especially now that we're seeing a switch towards the software-defined vehicles, there's a lot of buzz around that. So all OEMs are trying to push towards software-defined vehicles. And if you look under the hood, what does that mean from an electronics architecture standpoint? It means that you're moving away from a domain-based architecture to a zonal architecture. And then it's essentially any type of zonal architecture, it's fundamentally it requires some high-speed bandwidth between different zones within the vehicle. It's never going to be less than 500 kilobits per second.
True.
And therefore, the only technology that's out there that's proven for automotive is Ethernet. So now we're seeing another big jump in Ethernet technologies pushing for different things that are needed on a zonal architecture. And we're seeing a lot of advancements, like with ADI, for example, they call it E2B, meaning it's a protocol on top of it's a protocol on top of Ethernet. But what this is you can buy a chip from ADI to put in a let's say a central compute module, and the same chip or a different the same family of chips in a edge device that might be far removed from. So the central compute might be in one spot of the car, and actuator that you want to control is far removed from that. So that's essentially what a zonal controller is. You're combining computational or all the decision making into a single ECU, and what that means is that single ECU is not going to be able to have direct wires going to every sensor and actuator in the car. So it means that things are going to be controlled remotely over Ethernet. And so what E2B is, it's really nice because E2B makes the host computer think it's talking directly to direct I/O.
Interesting.
So for example, you can write into the E2B chip I2C messages. So I don't know how technical you want to get here, but
software is not my forte. Sorry.
Yeah. So there's some very popular onboard communication methods for chip-to-chip communication on a single PCB, and the two most popular are SPI, or you call it SPI bus, and then an I2C bus as well. It enables chip communication on the board, on a single board. That's how it's been used for decades, and still is very popular. It's ubiquitous on every PCB. So what the E2B technology does, it enables the software that you're writing to think it's actually connected to a chip right on the same board, when in fact it's actually remotely removed from by any distance over Ethernet. So we're seeing some very interesting technology. That's the first application of that technology is going to be on I forgot which model it is, but on BMW. They're using it for lighting control. So it's already a successful technology. There's another competing technology that's somewhat competing from Texas Instruments. So we're seeing a lot of.
I mean, if ADI is involved, yeah.
Yeah. So the TI and ADI are sort of like the arch enemies of they attack a lot of the same space. So yeah, we're seeing lots of development, lots of switch from traditional architectures domain towards zonal, and other developments like I've seen on your on your YouTube channel, the ether loop from Tesla, and there's many other applications of Ethernet. So we really see it going widespread, and it is starting to eke in. Getting back to your original question, it is definitely starting to it eliminated most Ethernet, but now it's even starting to encroach on other standard networks that we would normally have, like CAN, controller area network. It's definitely
my next question. That one, yeah.
Yeah, I've seen architectures, or I'm working with OEMs that have architectures right now where controller area network does not exist in the vehicle,
That's
It's
impressive.
been replaced by Automotive Ethernet, and more recently, I could ramble on like this forever. Hopefully I'm not rambling too much, but there's just recently in the last 2 years a new Ethernet technology that is a shared medium. Just like controller area network is a shared medium, when that means that when you hook up ECUs to the network, all of the ECUs are electrically connected to all other ECUs, and that leads to easy wiring and compared to the other choice, which traditional Ethernet requires a switch. So you have an Ethernet switch just like your house. In a car with traditional Ethernet, it's only point-to-point in an electrical standpoint, and that means you need to introduce an Ethernet switch in order to have more than two devices talking to each other. And that the fact that you got to go point-to-point to an Ethernet switch and introduce this expensive piece of equipment, which is the switch, makes Ethernet less favorable from a wiring standpoint and from a cost standpoint relative to CAN. And so the Ethernet community, and I was, marginally involved in this as well. It's pretty exciting to, develop these standards. It's called 10BASE-T1S, and 10BASE-T1S means a 10 megabit Ethernet, which is slower speed than the original introduction of Ethernet, which is 100 megabit. But it's a shared medium. It's a bus-based technology. So that means now Ethernet is on the same playing field, the same level playing field as far as wiring, connectors, with this new 10BASE-T1S technology. And we've seen OEMs literally switch from on zonal applications from what would have been in the past CAN to 10BASE-T1S. And the huge advantage of 10BASE-T1S over CAN in that sense, even if let's say if there's cost parity and wiring parity, everything else being equal, the big advantage of 10BASE-T1S is that it's an actual Ethernet technology. That means that if an ECU on a CAN network sends out a message and you're going across the zonal architecture, and the zonal architecture, the base network the framework is Ethernet. It means you're going to have to translate that CAN message
back to Ethernet and back out again.
And back into CAN on the other side. So if you have Ethernet everywhere, there's no translation. And that translation, CAN to Ethernet, is again going to have to be done in software somewhere, right? And so OEMs are like, software costs are out of control. And so anything that brings less software development, less cost from that standpoint, and less risk of bugs, it's a huge push. And so we really see 10BASE-T1S taking off like a new technology. Like I've never seen any technology take off. It's been very rapid adaptation.
Yeah. So in developing other architectures too, again, dancing around NDAs here, can't get into details. So we speak generically for a while. The concerns going from CAN to Ethernet, we'll start off with the wake-up time. The concern being Ethernet's slower to wake up, CAN is already there, especially in a zonal architecture on an EV where you quiescent current draw and all that kind of stuff. We want to keep it super low.
So for wake-up times, there are newer automotive-specific standards that you can get with automotive-specific Ethernet physical PHYs or chips.
Okay.
And part of that is automotive-specific sleep and wake. And there's actually a group that Intrepid's involved with called Open Alliance. Okay. And Open Alliance is specifically only automotive companies that are tackling challenges like this that are specific to the automotive industry, networking, and coming up with solutions, standardized solutions for Ethernet. So like one is TC10. It's called Technical Committee 10. The name doesn't mean anything, just means there's a automotive technical committee to create a specification for exactly that, sleep and wake for Ethernet chips for automotive specific purposes. And the big difference between outside of automotive and inside of automotive, there's two major things when we talk about sleep and power management in general. First thing is as you mentioned, it's the wake up time. Mm-hmm. Like the general rule is any ECU in the vehicle, from the time that you try to wake it up from a low power state to fully functional, is 100 milliseconds. Right. Yeah. And if no one's going to wait for their computer to boot like 2 minutes in the car. Yeah. So that's a huge difference. And outside of automotive, you just don't see that requirement at all. And it's foreign. The other thing is the actual power requirement. When I remember when I was first talking to some of the guys that were experts in normal outside of automotive Ethernet, they're like, yeah, we have energy efficient Ethernet. We can put our PHY in low power mode. And I was like, well, how much current does it draw? And he's like, well, it's, at 12 volts, it's something like 150 milliamps. And they thought that was low current. So they thought that was very low current. And in fact, in an automotive
window
world,
regulator it is.
Yeah. So the general specification for an ECU in the automotive world is that each network connection, like controller area network, LIN, FlexRay, MOST, you name it, automotive technology, when it goes in the low power mode, we're talking 10 microamps, 100 microamps maximum is what you want to achieve, such that so that you don't drain the battery if you just leave the car sitting there for a month or something. So that's the real big differences. But we're sitting here now in 2024. There are so many companies now that have actual automotive specific chips available with the power management, even cybersecurity, MACsec design adapted for automotive. And again, so cybersecurity, most of the things that are not used in automotive, we're bringing them in and using them in automotive, but we're finding that the initialization phase or the communication phase of exchanging keys generally is in a number of seconds.
Yeah.
When you're working with a web browser, but in an automotive, that's just not acceptable.
Right.
So we're still got this 100 millisecond. So there's a lot that's happening, but the market is pretty mature for point-to-point Ethernet. So the first point-to-point Ethernet started becoming, I think, chips becoming widespread available in 2015 timeframe, if I'm not mistaken. That was 100 megabit Ethernet. And now since then, we've got gigabit Ethernet, 2-wire Ethernet for automotive, and we also have multi-gig Ethernet, and the multi-gig comes in flavors of 2.5, 5, and 10G. So we have a whole family of technologies now on Ethernet. They're all Ethernet. They're all covered in the book, how the different physical layers work for the different speeds grades. And so it's not just one technology. It's a family of technologies that can be used in almost every area in the entire car at this point in time. So we are seeing wide adaptation of Ethernet, and there are some OEM companies that are publicly really pushing for an Ethernet only type of entire network architecture is Ethernet only. And the one that's most vocal about that in the world is BMW.
Doesn't surprise me knowing them.
They're the original ones that really pushed Ethernet onto the market. So
okay, so as most of the automotive industry starts migrating from domain to zonal architectures, and then the power distribution through that, so Ethernet has the capability for power line communications. That's great for low current, low voltage application. Camera's great. How do you see adapting this to power a full zonal controller?
I don't see that it's possible to have, or even makes sense to have Ethernet deliver power to an entire zonal controller. When we look at the central compute module and when we look at the zonal controllers, those ECUs are massive, power hungry.
Often this footprint.
Yeah, exactly. Often liquid cooled. The industry is reducing the number of ECUs in the vehicle, but the ones that are left are monsters.
They're much bigger, much more.
And so the big ECUs in the car are not going to be able to be powered over Ethernet. And it wouldn't make sense. You'd have to have the data line so thick just to deliver that amount of power to the ECU, even if you're at 48 volts or some higher level of voltage. The current that's required requires a much larger cabling than you have with data cable.
Because we're using 0.35 typically, right, inside of one of these.
I don't know the diameter stuff off the top of my head, but it's certainly power to a zonal controller. Certainly a central compute module is going to require some pretty hefty power cabling too, specifically for that. But I will say that also point-to-point Ethernet, we have what's called POODLE, power over data lines.
Okay.
And that's, again, an automotive adaptation of what you see power over Ethernet, right? Power over Ethernet used heavily for standard Ethernet for cameras, security cameras.
Security cameras a lot.
Very popular for that. So power over Ethernet's a very functional and good technology. However, power over Ethernet requires 4 wires.
Yep.
So it's impossible to have that for automotive. So automotive groups got together and said, we've only got 2 wires. Can we still do power over Ethernet? And the answer is yes. And we do that. We have a specification, but then it's renamed for just automotive name, Poodle, just like the dog, but it's PODL, Power Over Data Lines. So there's that is available, and my expectation is that will be. I do see that starting to be used for applications where, off of the zonal controller, you might have smaller device, maybe even it's a camera.
Yeah, the cameras on Ethernet tend to be the go-to for that.
You can have power, lower powered actuators and sensors can be powered just with Poodle, PODL.
Okay.
Yeah.
What about radar applications? Because when those are pulsing, that's typically a bit higher current than when they're just sitting idle.
Yeah, I don't know the specific requirements for radar. My guess is that the radar would also need to be specifically wired for power. It's really just the maximum power the max power that we can do over PODL. Don't remember off the top of my head, but of course it's in the book.
Yeah.
Don't quote me on it, but something
I'm not all the way through
it's something like 60 watts, something like that. So it's not.
Okay.
It's a decent amount. It can do a lot with it, but the limit is what it is. And then of course the wiring for the network, you want to have it as small as possible, just to save on weight and cost.
And the band radius and the packaging. Yeah, but then you start fighting the other side of that of assembly and durability. Then
right, exactly.
Every program I've ever been on, Ethernet connectors and FACRAs are always like the number one broken item in the harness.
Yeah. Oh yeah. That is a big challenge for adopting Ethernet, and I've seen it in my life, especially any company a lot of companies that are adopting Ethernet, where their engineers or technicians or whoever, they're accustomed to CAN.
Yep.
And CAN is very forgiving when it comes to wiring.
Yes, it is.
Compared to Ethernet. So in the past 30 years, you could just go to a car, kind of disconnect the connector and plug in a tool to monitor what's happening, or even when you do your mule builds or something like that, you can, the exact cabling and the twisting and the connectors. It's not so stringent. Like CAN is, like I said, very forgiving. And when you get into the Ethernet, you're in a whole new world. And I see so many people that used to work in CAN, they're trying to work at the Ethernet. They're like, it's not working. It's not working. Well, it's if your cabling is not exactly right, even bend radius, it's not going to work. And so that's really was. And even in the early days, we had a lot of skeptics in the industry where they were thinking that automotive Ethernet was just too sensitive, and automotive companies wouldn't be able to get the quality control of the wiring harness with bend radiuses and all the connectors for the whole vehicle. It was a lot of people were skeptical that the auto industry could actually meet the requirements for this cabling that's much higher stringent than compared to CAN because of the higher bandwidth. But we're looking already in the past that the Ethernet has been released and on the road for many years now. So but certainly a lot of people were skeptical about it at that time.
The other issue we fight too in the automotive world is typically the manufacturers of the cable are not the typical Yazaki, Sumitomo's who are doing the CAN and the LIN stuff. And so now we've added in this new layer of the supply chain.
Right.
Do you see the harness manufacturers really embracing this to try and cut out a middleman, if you will?
I do see. Well, I know for a fact that I don't know what I can say publicly. Let me think about this, but certainly
we can edit out later if we confirm.
some of the bigger names that you mentioned on cabling, they are buying tools from us to test Ethernet cables. Good. Okay. So let's just say the big names in cabling, like the Yazaki and Delphi was in it for a while. There are some others, some Korean and Chinese manufacturers, but they're definitely. I know they're making Ethernet into harnesses because they're buying the tools from us.
Good. It's about time
to test those harnesses. So they must be doing it.
Yeah, from a cost standpoint, that's always been a linchpin for us. It's we want the coax in this, but it's another 20% because it's a new supplier involved.
Right, exactly. Yeah.
It's it's been this way for how long?
Specifically with coax. Coax is different. The coax type of cabling is definitely more difficult than compared to when we talk Ethernet. Most of the forms of Ethernet for automotive specific are not coax; they're just twisted pair.
Right.
And then you have from 10 megabit, it's twisted pair just like CAN. at 100 megabit, it's twisted pair. And when you start getting into gigabit and higher, most companies are going with shielded twisted pair, just to again, the stringent, the requirements around the balancing between the two conductors is very important. So like if it's twisted pair, the twisting, it's got to be evenly twisted, and when you go to and then shielding gives you that extra boost of signal quality that you can get into the higher bandwidth. So we see again below gigabit speeds, it's just twisted pair, just like CAN, FlexRay. Same type of cabling, and then when we get over a gigabit, it's shielded twisted pair.
Okay.
For most Ethernet applications. Yeah. And in coax, we see coax still, but that's more for SerDes applications, and that would be like high-speed uncompressed video data, which is another interesting conversation, because the people in the industry that are involved in Ethernet, they want Ethernet to also be used to replace the LVDS technologies, the serializer, deserializer technologies, the two big ones that are out there called FPD Link from Texas Instruments and GMSL2 from
okay,
ADI.
That's interesting.
Yeah.
I've been approached the other direction on that one, of like trying to get away from coax and Ethernet for ADAS, well, camera specifically, to go back to low voltage differential signal, just to save on the headers for the most part.
Yeah. In my view, there's a lot of discussion. Like I said, there's a lot of people in the Ethernet community that want to push Ethernet technology into the camera space, meaning high-speed, uncompressed video data that's often used for ADAS and autonomous vehicle applications. And the data has to be uncompressed, because as soon as you compress anything,
you've lost fidelity.
You not only lose fidelity, but even worse for autonomous control is you're introducing a significant latency that's dynamic as well. So you can't, there's no such thing as compression or authentication or encryption without adding a latency. It's this fundamental,
every
physical fact of reality that you're gonna, if you're making computations on a data stream, you can't use that data stream until those computations are done, like compression or decompression or whatever, authentication or encryption, decryption. So, but my view is that the SerDes applications, this is GMSL2, this is LVDS technology, have always been lower cost, higher speed, more adapted because of the connectors, because of the pinouts, than compared to Ethernet. So I don't think, my personal opinion is that I see a tough time Ethernet replacing the LVDS technologies specifically for cameras, just because the camera market is used inside and outside of the automotive industry. It's ubiquitous everywhere, and the chips are so low cost, and you put the chip down on one side, chip down on the other, and it just bites. It's just
done.
Bites in and out. There's no software involved. As soon as you introduce Ethernet, it's a packet-based only technology, which means you take a video stream and you have to packetize it, and then you have to unpacketize it at the other end at wire speed. And we're talking about, when we talk about uncompressed video data, we're talking 10 gigabits minimum.
Pretty much,
So if you calculate like a standard HD, just a standard HD video with color, how many pixels that are uncompressed, do the math, and you're looking at multiple gigabits per camera. So those technology, even if Ethernet could support the bandwidth, which it can, they're working on even 25 gigabit Ethernet right now on 2 wires. So Ethernet will be able to support the bandwidth, but again, it goes back to the same. Why is A2B so popular in automotive space or audio space? It's cheap and it's easy to implement. That's what people forget, is this idea. I put a chip down here, put a chip down here. I just shove in bytes on one end, I get bytes out the other end. Ethernet does not provide you that. Ethernet can't do that at the moment. And so if you want to take a stream data like a camera, where you're just streaming data over in one side and coming out the other, then there has to be some type of protocol. As soon as you say protocol, there's maybe software or firmware involved or some type of FPGA work, and you're adding complexity for no benefit whatsoever. That's the way I see it. But there is an organization out there called Automotive Serial Alliance, ASA, something to watch out for, because the industry generally likes standardized technologies.
Yes,
One thing
they
that
do.
automotive industry likes is controller area network. It's the same whether it's a Mercedes, whether
Yep.
it's a Hyundai or whatever. Any car in the real world that has controller area
Pretty
network.
much.
It is a standardized technology across the industry. And so the automotive Ethernet is just like that. It's identical. Now you can argue that one of the disadvantages of the SerDes technologies is all proprietary. In other words, if you're using FPD link, you're buying it from TI, and that's it.
As soon as you say proprietary, they start puckering up and going, those royalty fees. Yep.
So there is an automotive serial alliance pushed again by a particular person at BMW and others that want to standardize the SerDes world. Now, the silicon manufacturers don't want to do this, okay? I don't think they have a business motivation to do it. So this has been an organization where OEMs are kind of trying to push the SerDes community, but then again, the problem still is that if you try to push a standardization, like with ASA, Automotive Serial Alliance, then by the time that you have the standardization, your technology is already like a generation too old.
It's obsolete.
Because the proprietary technologies come out faster. They don't have to worry about standardization. Everyone agreed. None of that matters. So it's going to be tough, in my opinion, to see SerDes encroach into the world. Ethernet encroach into the world of the SerDes. That's my personal opinion. But it's an exciting industry because we get together. We have trade shows. We have, IEEE is where we standardize a lot of the Ethernet technologies. We have Open Alliance where we get together for a lot of different things. And the same people that are working on zonal architecture are the same people in these meetings, the same people working on SerDes. So we always have very good dinner time discussions when we have a couple beers maybe and open up about our real opinions about where the industry's headed and so forth. So it's a lot of fun, and there's a lot of competing technologies out there, and there's been some really big winners and big losers, and that'll continue to be the case.
So I'm glad you mentioned the silicon, 'cause that's another one that comes up a lot too, because from domain architecture to zonal architecture, domain guys, it's like, this is my little world. That's all there is to it. And the wiring guys are, this is my own little world. And I don't care about anything else. But as soon as you go to zonal, all of a sudden you have to have a system level overview.
Yep.
And now it's not just the cost of the connector, the cable, the crimping. Now I got to worry about the header on my board, and I got to worry about the chipset too.
Yes.
Are we getting lower cost Ethernet chipsets anytime soon?
There's lots of competition. So we are definitely seeing, Broadcom came out with the first one, but they've lost a whole bunch of market share. I doubt they were like the dominant one for a while, for maybe 4 or 5 years. And if you look at the cars on the road, they're probably the still dominant one. But other companies like Marvell, for example, have come out with a more comprehensive chipset, meaning it's a whole family of switches as well as PHYs for 100 megabit, 1000 base T1, which is gigabit as well. And then also NXP, which has traditionally been the one that NXP has been the company that supplied most of the CAN transceivers to the world. And so they are the ones biggest to lose if Ethernet takes off. So of course, and it was interesting to see because NXP for a couple of years didn't think that Ethernet would be functional, and they kind of,
that's a gamble.
it was a bad gamble, and they waited, and they were a couple of years behind the rest of them. So we see, and they lost a lot of market share as a result, and didn't get on the bandwagon of Ethernet, and they came late to the game. But nonetheless, we have Texas Instruments is a good sized player in the automotive Ethernet space for chips. Marvell, Broadcom, NXP, and also Microchip now. Microchip was the first company that came out with 10 base T1S, the 10 megabit Ethernet. That's the shared medium. So they were the first ones out there, but ADI has chips as well. ADI is doing really well in that market, the 10 base T1S market. So there's a lot of competition now. So definitely the price, there's a lot of price pressure on the downward.
There definitely is
side. Compared to the early days. In the early days, you had one silicon manufacturer, right?
Pretty much, yeah.
But now it's a pretty competitive marketplace. So I would expect that you'll see the silicon coming down in price.
I would definitely like to see that because we go through the chipsets and Ethernet's like $10 or so, and they would drop the LIN and we're like with $2.
Yeah,
and it's
right.
really
LIN
hard.
Is much more. Yeah, LIN is out there still, and I've even seen with some OEMs. LIN is becoming more popular because they've replaced CAN, and then they've implemented 10 base T1S. They've implemented automotive Ethernet, but you still have this need for this very simple, low speed. If you're doing a door switch, same thing. That's the common one. You're doing a door switch. You're doing some lighting. You're doing window motors rolling up command. These things.
Interior lights is like that's just LIN's playground.
Yeah, I mean you don't need any kind of speed. And as long as you can keep the distance, LIN is one wire. You can't, I don't care if you have an 8-bit microcontroller, just any I/O pin on a microcontroller or any type of chip whatsoever can do LIN. So you don't even need any type of controller or special chip or any. So LIN is still. I expect LIN to be a survivor long term.
Same here. Yep.
Yeah, my expectation. It can over time. Probably will go down some, but what we're going to be here 10 years from now, and there's still going to be CAN around. The automotive industry doesn't move that fast. There'll still be domain architectures in 10 years.
Yeah, I mean, I think restraints and powertrain, it's going to be really hard to get them to jump out of CAN.
And we see that still where some companies do a whole zonal architecture and powertrain separate.
Yep. Well, in some cases, the OEM, like the powertrain, is a separate company. So
right, yeah, that's true. And it's funny because you mentioned about domain architecture, where domain architecture, the main characteristic is that you got one network and ECU is dedicated to particular
those functions,
functionality in the car, like powertrain, HVAC, or lighting. Those are typically all separate networks. Interesting, though, is I always love the joke, because if someone hands me an architecture for domain vehicle, I can, with high accuracy, guess what the organization of the company that produced that vehicle, what it looks like.
Yep.
So pretty much you can overlap the organization on top of the domain architecture, and they look the same.
Where the brackets are also tells you where the split is.
So with the challenge, I think, for zonal is, oh my goodness, now you're smashing all these people together on top of one network and inside of one ECU even.
Yeah.
So you're seeing HVAC and lighting people
That's
come
where the
together.
Efficiencies are, though.
And, right. But in the past, those people never even spoke to each other their whole careers,
No, they've got 30. Yeah, so I do like the zonal architecture from the standpoint of you have to actually coordinate with the other groups.
Right.
So I've already got a wire running here. Can I just run it in the same bus? You've got the bandwidth for it. But in old days, no, I have to run 4 more wires next to it.
Right. Yeah. And and it is a challenge for these large organizations to have, their internal groups or their silos.
There's silos of excellence.
Cross communicate. It's not.
There's some growing pains there.
Forced to do in the past, and they're going to be forced to do it in the future.
That's I think where the Teslas and the Apteras of the world.
They're working from a clean sheet.
Exactly.
So that's the big advantage of all of the startups, Rivian, Tesla. They don't have a history there. They don't have an organization there that has a history of. So they can, that's the beauty of Tesla. They just, Elon just does whatever he wants. He doesn't care about.
Coming from a software background anyway, so it made sense.
Yeah.
So going through history, as we're coming up to our time limit here, what got you into writing the book? What's the whole history behind this one?
I just saw my personal ambition, I guess. I had some personal ambition just to try to, and also for the company, for Intrepid Control Systems. I definitely saw right at the beginning, as soon as it didn't take long for me to realize that automotive Ethernet was going to grow to be a ubiquitous technology for automotive. Because at that time, let's go back in history, 2015 when we started the book. Or that's when we released it. It might have been 2012 or 2013 when we started. I don't remember the dates. Don't quote me on it. But the first version of the book, we're on the second edition now.
Okay.
But back then, it didn't take much to realize automotive Ethernet was going to be a ubiquitous technology, even despite the naysayers.
Yep.
Fundamentally, we're sitting on 30 years of controller area network. It has not changed that much, right? So the growth of the need of the network and the bandwidth for 30 years has gone skyrocketed.
For sure.
And controller area network is, hasn't moved the needle that much. You have CAN FD, which you can go a little bit faster, and 64 byte payload max, which improves efficiency of the network and so forth.
Right.
But compared to Ethernet, it's still nothing.
Way too slow for that.
It's way too slow. It's way too slow for any type of streaming control area now, any type of video or audio streaming. Way too slow for that. So it didn't take much to realize that Ethernet was going to be a huge thing. There's going to be a lot of advancements, a lot of things that had to be done. Even back then, power management didn't exist.
Yep.
So I'm like, this is a chance for my own personal ambition as well as the company to get out there as a market leader if we can create a book that's sort of we come out with multiple editions because the technology is still changing, and it was basically just help in marketing and get our name out there as a leader in the technology. and it's worked really well. It's a lot of people. I travel all over the place, and in the industry within our specific niche of automotive networking, it's a pretty small community. I would say it's a pretty niche type of focus, and it's been great. A lot of people have said they use it as a reference, that's what it's intended to be. It's just
I've been using
a
bullet
reference.
points to cite in some projects already.
And it's been a lot of fun. And I've worked with other people. The first edition was there was a person by the name of Robert Boatwright who was originally working at Apple. He did work at Apple for a period of time, as well as Harman. So he had this background in both.
An interesting blend.
Yeah, Harman was one of the largest, I think, infotainment electronics provider for the automotive industry, and he worked there and also in Europe. So he was kind of known in the industry as a leader he's since retired, but a leader for a lot of the protocols that were brought in by Automotive Ethernet. Harman was also a company working closely with BMW.
Yeah, I can see how they'd be involved with that.
To push the technology as a supplier. And so I got to work with great people on the other authors of the book, both at Intrepid and externally, and it's been a lot of fun. The first year the book came out, we did what we called we just marketed book tours. Let's do a book tour, Automotive Ethernet, and there was so much interest in the technology at the time. No one knew anything about it. Then back in 2015,
true.
And so I went around the world, and we would book out we'd get a hotel room like in China, and we would get several hundred people per event, and then we'd do one per city. Shanghai, Beijing, China, Shenzhen, Shanghai, and then Beijing. We did the same thing in India with Chennai, Bangalore, Pune, and other areas. And so we did this big tour around the world, and boy, I'm telling you, even in Europe, all around Europe, Germany, Sweden, France, England, not specifically part of Europe anymore, but and even in America. So it was great. It was fantastic. It worked out really well. The original book, a lot of interest, and then fast forward to today, the second edition of the book. There's so much new now, because back then it was only even 100-based T1. Right. There was no power management. People were still working on technologies for really good time synchronization and other protocols like clock redundancy, so that you can have a network that's Ethernet-based network that supports safety critical applications. Yep. A lot of things have been developed since 2015, and all of those new developments are now in the second edition book, in addition to 10-base T1S, which is the Serried medium automotive Ethernet, 100 megabit Ethernet, which is the original. Gigabit Ethernet didn't exist back then, so that's new, and then all the multi-gig technologies as well, all the way from 2.5 to 10 gig.
So what do you think? What does Intrepid do to stay ahead of your competition?
Yeah, the biggest thing is the owner of the company, Dave Robbins, the founder, is always, he recognizes the biggest advantage for a company like Intrepid that supplies tools. So we supply engineering tools for the automotive industry to do network communication, basically. And whoever has a tool that functions on the market first wins.
Yes,
that is the main thing. So we're always out there. This is why we're part of IEEE. We're part of Open Alliance. We're part of all of these networking communities with OEMs involved around the world. We fly out there, we do the conferences, and we talk to the engineers at the OEMs. What's coming next? Anything new? What's happening? We have great relationship with silicon manufacturers, especially Microchip and ADI. And ADI is one of the leaders coming out with a lot of technologies that's been so popular and so successful, like GMSL2, like their whole chipset for 10-base T1S. Very popular, very successful. They have the wireless BMS. We also have a tool for wireless communication. That's also ADI is the dominant player in that market.
Between them and TI,
TI is a big competition to that. But ADI's been the dominant player. Let's put it that way. Yeah. They're the first to market, and that's the biggest thing is we look for any technology out there that engineers have to develop, and then we try to get a tool on the market for that technology as soon as we can.
I guess last question, what do you see as the next steps for Ethernet in the automotive world?
Oh, that's a good question. I believe that there's been a lot that's happened over the last 5 years, specifically on the physical layer and getting automotive qualified wiring, silicon from all the way 10 megabit all the way up to 25 gigabit. That's a huge family, huge, advancement. So right there lays the foundation for Ethernet to be ubiquitous in almost every car that has significant electronic content. So Ethernet's already on that path. But the exciting things that are happening now is at the protocol level and all the technologies that are getting built on top of the Ethernet. So think about the automotive industry is in the same spot the internet was in the 1990s.
Okay, yeah.
Everyone knew what it is. Everyone started using it, the internet. But compare technologies now, websites now, compared
the
to
original
1990s.
Amazon, yeah.
Right. So if you compare that, it's just all of the software, the design, software technologies, and protocol technologies are still, there's so much happening on top of Ethernet. So we're just seeing the maturity of, there's a good foundation there where there's high bandwidth, good quality network. And if you give car companies high quality, good bandwidth network, they'll find uses for that bandwidth in terms of new protocols, new functions,
cybersecurity is the big one nowadays.
Yep. So that's one thing that we're working on right now is at Intrepid is MACsec, Media Access Controller Security. It's been a standard outside of the automotive industry, but again, automotive industry's taken it in as an open alliance committee. And we've adapted it for automotive purposes. So we see a lot of the new silicon coming out supporting MACsec directly in the PHY. A lot of OEMs are saying this is required. And then there's MACsec key agreement. Those are just some new ones. GPTP, generalized time precision protocols used for point-to-point network, needed some adaptations for shared medium. So that's another thing that got updated and adapted. And we're seeing that for a million other applications on top of Ethernet. So it's development is going gangbusters like crazy in the networking space.
All right, very good. Well, thank you so much.
Yeah, thank you for your time.
Yep.
It was great being here.
We good?
Yes. Is there anything you want to plug or say?
Advertise, shameless plug.
Oh, shameless plug. Yeah, no, just the company in general, Intrepid Control Systems. We have a great book, Automotive Ethernet, the definitive guide. And we have we give away free posters on the technology as well. And check out our website, www.intrepidcs. It's kind of hard to spell sometimes, intrepidcs.com, intrepidcs.com. And what we do is we make automotive networking tools. And another big part of our business that's related is we make in-vehicle data loggers too. So that's also something that we would love to hear from anybody if you're interested in in-vehicle data loggers, any type of automotive networking tools, automotive networking in general. Give us, get on our website and send us an email. We'd love to hear from you.